HVAC 360, episode number 77, Ice Storage Systems with Calmac Manufacturing. Hey, welcome back, everybody, to another episode of HVAC 360. I am your host, Matt Nelson. This week, we're going to be diving into the archives a little bit for an interview I did with Paul Valenta, who was the VP of Sales and Marketing at Calmac back when I interviewed him on the floor of the AHR Expo in Chicago in 2015. It may be from 2015, but it's still good content. So gives you an idea of what an ice storage system is. And again, just to give you some perspective, it's not something that you see all the time, but like with most of the things here, it's just an educational and a learning experience for you. A couple of things, it's 15 minutes long, so it won't take that much time out of your day. And a couple of other things to remember is that ice storage systems typically are applied, or the reason that they're applied is because they give you advantages, financial advantages, when you're talking about energy and the cost of energy. A couple of different ways that they do that, and Paul touches on them briefly when we talk to him about the Calmac systems. But the first one is the change in the rates. In the morning or in the peak of the day, say 12 noon, they're going to be higher than they are at night. Now, and again, I'll take a step back. This doesn't always necessarily apply to every situation because every electrical utility, depending on whether they're unregulated or regulated, everyone is going to be different. So you're going to have to look at your specific area to see if this really applies to your type of project. The second thing is the demand charges for electrical. Now, to understand demand charges, you may want to Google this a little bit more. I'm going to give you a kind of a brief synopsis of what demand charges, at least in my mind, are as best as I can explain them to you verbally over the air without me actually showing you some details or mentioning numbers. But demand charges basically are a peak load that the utility sees in a billing cycle for you. It's not energy usage, but say you turn all your equipment on at one particular time during the day and you use, X number of kW. Well, they kind of assume, regardless of whether or not you ever reach that peak again during that billing cycle, that they're going to have that available to you just in case you ever, you repeat that demand. So they kind of use that to anticipate the load across a electrical grid. However, if this is one of those things where if that peak demand is short, and they measure in 15-minute intervals, so it really has to be longer than 15 minutes that you're kicking something on and off. But typically, like during the peak of the day, you're going to be using all your cooling, and that's going to drive up your demand charges. So if you're just doing that one or two times during a billing cycle, your demand charges are going to be really, really high, even though your electrical usage might be low. If you're constantly using that type of demand, so it's pretty steady and you're not really peaking, then demand charges is going to be, it's not going to really change. But your electrical usage is going to far outweigh the cost of your electrical usage is going to far outweigh what you're actually paying in demand charges. So that's kind of demand charges in a nutshell. The third thing that you do is load shedding. And again, you can do this, typically things that you do load shedding with in a building. Ice storage is definitely one of them. Larger institutional people will have generators that they could kick on to supplement their electrical usage, and some combined heat and power plants, some CHP. They can use like fossil fuels, natural gas, things like that to generate electricity rather than draw from the grid. So those are kind of a couple of different quick ways that you can shed load in that type of situation. All right. I think that's good enough. So without further ado, here's my interview with Paul Valenta. We're on the floor of the AHR Expo here 2015 in Chicago. I am standing next to Paul Valenta, who is the Vice President of Sales and Marketing for Calmac. How are you doing today, Paul?
I'm doing great, Matt. How are you?
I'm doing well. So tell me exactly tell me a little bit about Calmac if the people listening aren't that familiar about it.
Sure. Calmac Manufacturing has been around since the 1940s, and for the last 25 to 30 years we've been making energy storage products that feature ice. And so we're kind of an air conditioning system or a battery system for an air conditioning system. And so what we do is we'll make air conditioning at night when electricity is about half price. And we'll use that stored cooling the next day to either offset or augment a reduced size chiller. And by doing this, the customer can reduce cooling costs anywhere from 20 to 40%, depending upon the kind of building they have and what part of the country they're in.
So, I mean, when you talk about ice storage, anybody not familiar with ice storage, because it's not a common thing to find in most buildings. So what does it look like from the outside?
Well, we make round tanks that actually look like a huge battery. And it's about 8 foot in diameter, about 8 foot tall. It's a modular kind of system, so it's very, very repeatable and modular in that the same job with one tank is designed and operates the same as 100. So we have what's out in the field called an ice tank farm. It consists of multiples of these batteries. It works with a conventional air-cooled or water-cooled chiller and a building. So we'll at night circulate brine through a chiller. The chiller makes ice, circulates that through the ice tanks that we build, and inside the ice tanks is a coil. And the brine inside the ice tanks might be 25 degrees. Surrounding those coils is just water. So we'll freeze that battery solid during the nighttime process. During the day, then, what happens is we'll circulate and cool the building with a conventional chiller. And then as the load increases above the size of that chiller that's installed, or there's a price point, then we'll use that stored cooling to either offset or augment that reduced size chiller. So it's like a battery for your air conditioning system, and we use it to offset cooling costs.
So when you talk about offsetting cooling costs with the basically you're talking about demand charges when the electric generation comes to a certain point. I mean, time of the day, say noon or so, when everybody wants to use the cooling because it's a peak load scenario. That's when you'd kind of want to switch over and say, hey, you know what, I can pay for the cost of the product just by using that in a peak scenario.
That's right, and so if you look on the cost of $1 per ton hour, the $1 per ton hour that was generated at night might be half of what it would be during the peak of day. And when you think about what's happening on the grid side during a peak load day, the utility is working hard to make electricity available to all, and everybody's cranking up the air conditioners. And what they're using to generate electricity typically is the dirtiest generators, the one that they want to use for the least number of hours. And if people can move that load off peak, then they don't have to start those, and we can reduce emissions into the space. So there's benefit not only to the customer with lower costs, but there's also benefit to the grid and to society by reducing those emissions and not using those old and dirty peakers.
And I think that some of the electrical generator, some of those people that generate the electrical power, in an effort not to start that dirtiest power generation, sometimes if you're a large consumer of electric, say you're an institution or a hospital, they'll actually basically pay you for the right to call you up and say, hey, let's shut down the power, let's lessen the power, and obviously that's another scenario where not only could you go for that lower rate because you can shut off your chiller with the storage system.
Yeah, in deregulated markets, there's an operator that controls the grid. And the grid, when they need a call for power, they go out to the market. And the market can either go to, or the lowest cost could be a peaking generating plant, or it can be what we sometimes call a negawatt. And you can get paid just as if you were a generating plant. It's almost called a virtual generator using the ice storage. So there are options available to do that are out there in the deregulated markets. The other thing that happens in deregulated markets is you don't contribute to the peak demand during the peak periods, and utility providers like that. And so they can go out on the open market knowing that you're not going to contribute, and you can negotiate a better, lower overall rate using ice storage because you're a preferred customer, one that doesn't contribute to the peak demand. So not only can you reduce your demand, but you can also negotiate a better rate and, like you had mentioned, participate in what's called demand response.
Now, when you talk about the ice storage system in general, the chill, obviously getting chilled water down to a certain level, does that take a special type of chiller to be able to do that?
Most positive displacement chillers can make ice. So that would be a scroll or a screw or even a recip if those are still around. Some of the non-positive displacement centrifugal chillers can make ice, but they have to be selected for that at the time of build to have that increased lift. So most recips and scrolls and screws, no problem. Centrifugal, you got to make sure they can do that, so check with your manufacturer.
Excellent. So now at the AHR Expo here, 2015, what do you have that's new?
What we have now is a completion module. One of the obstacles to ice storage has always been it's a little more involved on the engineering, construction, design, and commissioning. And so what we want to do is take care of that obstacle by making ice easy. And what we've got here is a completion module that includes the pumps, the piping specialties, plate frame heat exchanger, the control valves to make it all work in the 6 different modes, and the control system to operate it.
So this is a complete package. Would you consider it a standalone package?
Well, you need to add to it the ice tank farm, the chiller, and power, obviously. But that's really it. It's making ice storage more of a ice-in-the-box or a unitary kind of product where it's plug and play. We've gone through the process of pre-selecting equipment sizes and configurations that fit about 80% of the projects we've thrown out in the market over the last 25 years. And we've taken those best practices and put that into the control system. And what we found is that the market really likes a prepackaged system. And it's one that offers the customer, I think, a very reliable and consistent product, so it operates the same all of the time. And one of the other issues that we've had with any, I think, ice storage system or water storage system is that when the current operator goes away, if he was there during the commissioning originally, he knows how it should operate. But when a new person comes in, she may not know how to operate that system and what the different modes are and what the equipment should be doing. And we've included that in the control system, so it's very easy to find out how the system should be operating. And we've created other dashboards as well, so the financial person might want to understand why storage is installed and might want to look at what the savings are. There's a dashboard for that. There's a dashboard for troubleshooting. There's a lot of different dashboards that can appeal to everybody that's going to look at the system.
Now, when you talk about dashboards, I think of something that's basically connected to some sort of web server that you can browse to and look at that. So I guess, how does it interface with, is the dashboard on the display? Or is a dashboard something that somebody sitting remotely at a desktop can do? And to kind of piggyback on that, how does it connect into your standard building automation system?
Well, it could be a part of the entire building automation system, or it can be a component that can talk to an existing building automation system. But the unit is designed to run the ice storage system. So if a customer has an existing system that they really like and understand the input and output, this can be an augmentation to that, or it can stand alone. It's internet-based, so you can look at it on an iPad. Give the controller an IP address. It can be looked at on the iPhone. And so it makes it very accessible to anybody that wants to look at it day or night. The alarms can go right to the iPhone as well if there's an alarm of some type that's been set. And it makes it very, very easy to look at the system and get an idea of what's going on.
So now, is there? Getting access to that. How do you set up the access? Because obviously, if it's on the internet, there's security concerns. How do you address that?
Yeah, there's an IP address, and you have to have a password and a logon name, and that can be set by the administrator, and the administrator themselves then can assign different levels of access to that. So you can have someone that can just observe, you can have someone that can maybe change temperature set points, or you can have someone with full access to look at trending and creating up different data that's available to look at. So there's different access levels that are available.
Now, talking about that trending and data, a lot of especially in the engineering circles, they really get interested in trying to analyze that data. How do you make it easy for them to get that data? Do you have a backnet connection that you're pulling information to the building automation system, or is this something? I guess how do you get the information out of your system?
The controller that we use has an application section. So there's a graphic section to look at dashboards, but there's also an application section. And within that section, our trend log is a trend log program. And you can set up trend logs that will measure any temperature set point for any amount of time or any time intervals. So it could measure, for instance, the ice inventory every 10 minutes or every half hour, and you could look at that log and compare it graphically on the same controller about how that works in relation to the outdoor air temperature or to occupancy. So there's a number of different ways you can look at what's happening to your system.
So now for ice storage, what's some of the up and coming things? What do you see in the future that's going to happen? Where's ice storage going?
Well, as we go, I think towards net zero, one of the issues is how do you define net zero, and what does that really mean, and how do the utility companies interact with that? And if you think of a net zero building, what you're looking at is the meter spinning one way or the other, with the idea that the site will generate as much electricity as it draws from the grid. The one component that it doesn't look at is the demand. And if you think about what the utility has to do, if the wind doesn't blow or the sun doesn't shine, the utility still has to provide the infrastructure to create whatever that building needs in terms of energy. Yet they don't get paid for that. And so I think net zero is going to have to be, or will be, an opportunity for buildings, and storage will be an opportunity for net zero buildings to make this fair for everybody to operate. Net zero, I think we have to have maybe a little bit better definition of what that is and how it works. But if you want air conditioning in a building, I think it's going to have to include storage. And it's not just ice storage. It's going to be battery storage. It might be water storage. There's going to be a lot of different technologies. But a building is going to have storage of some type in the future.
Right. And, I've listened to a lot of people talk about, net zero buildings and what that takes. And I think, I think we have pretty much the discussion of, okay, is it site, is it source, what is the boundary? But you bring in a good point, if an engineer says, hey, we're going to have so many, we're going to have 10 EUIs or 50 EUIs for a building, and it ends up being 75, the owner might get credit for it, or might anticipate a savings from the utility when ultimately they're going to get dinged for a demand charge because they're using cooling when they said they wouldn't be.
Exactly, and that's because the renewable energy that we depend upon is intermittent, and we just don't know when the sun's going to shine or the wind is going to blow. So we've got to have some kind of backup. And if you think about what happens with renewable energy, what we're doing is replacing fossil fuel, and fossil fuel is a form of stored energy. So somehow, if we're going to replace fossil fuels with renewable energy, we've got to replace that storage. And it could be on the utility side of the meter with pumped hydro, but there also has to be, I think, storage on the customer side of the meter as well to make this all work on a smart grid.
Fantastic. Anything else that you want to let the listeners in on?
That's about it. That's a good...
All right. Well, I appreciate your time, Paul. Thank you so much for giving us your time and talking about Calmac.
Great. Thank you. Nice to meet you.
All right. And we're back. Thanks again to Paul, even though it might be a couple of years late. Thank you for Paul for his time. Thank you for your time. I definitely appreciate you listening. In the meantime, I wanted to kind of I checked the interwebs and see if there was any update on Calmac that I could share with you as an update for this episode, because it is back from 2015, and there was one just recently, so I'll kind of read this a little blurb that I found on the internet. Attention, Calmac joins Trane. That is November 7th of 2017, so based on the release date of this, that's not too long ago. On behalf of Calmac, on the Calmac team, we are thrilled to announce Calmac is now officially a part of Trane, a world leader in creating heating, ventilation, and air conditioning systems, and a business of Ingersoll Rand. All right, so congratulations to the Calmac team. I hope that is a great merger for you, and the best of luck to what you do. So before I end, I have one request. If you do anything, and I really appreciate you listening, if you do anything, I would ask that you go visit the website. That's HVAC360.com. I kind of changed things up a little bit. Take a look at it. There is a newsletter sign up. So join the list, get on the list, and that'll give you updates of when I publish these podcasts and some of the other things that I'm doing, which are kind of exciting and a little bit more participation in growing the community. So I appreciate you listening. If you like the episode, pass it on, but definitely sign up for that list. And until next time, remember, know what you build and share what you know.